got the man on moon was this one, 43 kilohertz, 64 kb RAM. That was the controller on the Apollo 11. And Moore's law went into the picture. We had tremendous growth in computing power, transistor counts, and right now probably our phone is a million times faster than the computer that put the man on space. How does that translate to healthcare? Very interesting parallel. 2001, Eric Lander, Howard MIT Broad Institute. This is how big was the system that sequenced the first human genome. And now what we have is approximately a couple of orders of $1,000 portable genome sequencer available now in the market. And if you look at the trends, in health sensing, health data collection, the cost per genome has gone from 100 million down to close to I would say a few thousand. And the Moore's law is actually slower than the trend seen in healthcare data sensing and informatics. And we at Harvard MIT work on a lot of technologies, especially in these two areas, health sensing and big data. So I thought, why don't I give you a sneak peek of what's actually happening over there to give you what can happen in the future, in the next coming decades. So one of the things that we did in the lab at MIT is, what if we can build a camera that can look around a corner? And what if it can look around line of sight? Small video that shows how can this be made possible. So this was an experimental setup we made at MIT in which you had a wall and you had a camera looking directly at the wall, not at the mannequin, and we could know what's actually behind the sort of mannequin doing a bunch of imaging and optic techniques. 10-15 years, if you can bring it down to a form factor of an endoscope, can you look around body parts as you're doing your surgeries? Similarly, eye tests, I think, pretty important. Right now, the various methods to do eye tests are using phoropters, different techniques. What we were able to make was a simple device in which what you have is a normal imaging technology called hybrid images, and what you see on the left is a person looking at the device and he picks an image that she or he sees. So in the first step, she might see an 8 or a 5, the image changes, it stops, the person stops as soon as she sees a 5, and what you get at the end is your astigmatism, myopia, hypermetropia number. And these are kind of advancements that mobile devices, the whole smartphone in your pocket have allowed us technologists to actually achieve. Similarly, one of the projects that was pretty interesting done at Harvard Medical School was that when you enter into an ICU, there's so many, I would say, instruments bringing 25-30 signals onto your, for a particular patient, and how does a doctor monitor all of that at once? So what we did was we converted the whole signal into musical notes, and the whole idea was that if a nurse or doctor is going around and the person's health is fine, the music sounds good, and if any of the vitals has gone bad, the music goes offbeat. And it's very easy for an amateur musician to detect what's offbeat and what's not offbeat, and we were able to actually deploy that and see how normal certain cancer cells actually react with different music notes. One other technology that we did again at MIT was what if we can make a camera that can refocus or take 3D after you've taken a photograph. So we could just print a transparency using a normal inkjet printer, open an SLR, put it inside, take a photograph, and given this photograph in which the person is completely blurred out, I can convert to this photograph. Now this is cool, but how does it help in healthcare? Well, if you put the same camera on top of a microscope, suddenly what actually happens is that you can go and see 3D images of cells, of artifacts onto your slide. So again, made possible by combination of imaging technology, much advances in that, and healthcare. The medical mirror, the fun project done at the Media Lab.
Stand in front of the mirror. The camera detects your face.
What if the mirror can actually tell you your health signs and vitals? So it's a simple mirror with a camera, tracks your face, and can get you your heart rate, your blood pressure right onto the mirror itself. Now this is on healthcare technologies, and if you look at big data, I think we just talked about it. The amount of data that's coming into biomedical literature is increasing massively. Like in the last, I think every year about 500,000 articles keep getting added. There's genome sequencing data, there is PubMed, how can we bring the power of all the data into our day-to-day life for physicians and doctors? So one of the projects done in collab with Stanford was AMO, and the idea being that our urine may not have any biomarkers, but in the context of lung cancer, it's pretty important. So how can I use all the ontologies that we have, SNOMED, UMLS, and whatnot, and leverage the power of big data and genomics, proteomics, published articles, and create links between these ontologies under a specific context. So we were able to take from Stanford NCBO all 200 ontologies, take more than 5 to 10 million of concepts, and link all of them together under different context-specific ontologies. So here you can see a link between a drug ontology and a disease ontology under the context of, say, gene ontology. Similarly, some stuff done at Harvard Med is how can we integrate at scale genomic and clinical data. And this system called SMART, I think is the world's first system that can integrate EMR records, patient health records, genomic data, and give you an overall perspective of how a patient health looks like. So in interest of time and in summary, I think the big map of healthcare as we see it is the mobile phones, devices like these. This is the Google Glass, is coming in onto the market pretty rapidly, and you're going to have various breakthroughs in technology for health sensing and continuous health monitoring. All of that connects to the cloud, where you have from startups to big companies analyzing data massively and giving a proper feedback to the doctor, which then interacts with the patient over telemedicine or over mobile or over person, and this loop keeps on sort of generating itself again to enhance both health sensing and big data. And we feel at Harvard MIT that the day might not be far where you can have something like this, where you can use sort of a portable X-rays or on your mobile device combined with big data and do something really special. And with this vision in mind, we have sort of tried to start something in India where we can bring all these technologies or create all these technologies into India through our Harvard and MIT India initiative, in which we do a bunch of, starting with a bunch of workshops, going ahead into incubating fellows, incubating startups, and seeing how maybe cutting edge research or companies can take some of these ideas into market at scale into India. Thank you so much.